Hello guys, welcome to Physics Unlocked. I am here with problem of physics that is taken from thermodynamics, and this problem was asked in JEE ADV 2022. So in this problem, an ideal gas of density rho is equals to 0.2 kg per meter cube enters a chimney of height h at a rate of alpha is equals to this much value from its lower end and escapes through the upper end as shown in the figure. The cross-sectional area of lower end is A1 is equals to 0.1 meter square and the upper end is A2 is equals to 0.4 meter square. The pressure and temperature of the gas at the lower end are 600 Pascal and 300 Kelvin respectively, while its temperature at upper end is 150 Kelvin. The chimney is heat insulated so that the gas undergoes adiabatic expansion. Take G is equal to 10 and the ratio of specific heats of gas is gamma is equals to 2. Ignore atmospheric pressure. So we have to find out which options are correct. Which options are correct? So in option A, the pressure of gas at the upper end of chimney is 300 Pascal. Since this whole process is adiabatic process, gas is entering into the chimney at lower end and coming out of the chimney from the upper end, and we are given the following quantities. These quantities: pressure at lower end, temperature at lower end, and density at lower end, P1, T1, and ρ1. These things are given, and temperature at upper end, T2, is also given, 150 Kelvin. Let me assume the mass entering into the chamber as alpha. We can write it as dm by dt. So dm by dt is equal to m dot. So in option A, since the whole process is adiabatic, so it will follow the equation of adiabatic process P into V to the power gamma, that will be constant. If we write this equation in terms of pressure and temperature, then we can write P into P raised to 1 minus gamma into T raised to gamma, that will be constant. If we apply this equation at lower end and at upper end, so we can write this equation. So from here we can write the value of P2 is equals to P1 into T1 by T2 whole raised to the power gamma by 1 minus gamma. So we can find out the value of P2 from here as 150 Pascal. So the pressure of gas at upper end is 150 Pascal. So in option A, it is saying that pressure of gas coming out is 300 Pascal. So option A is wrong. Now coming to the option D, we have to find the density of ideal gas coming out from the upper end. So if we write the equation of adiabatic process, P into V to the power gamma, V to the power gamma is equal to constant, in terms of density rho and T. अगर हम इस इक्वेशन को इसमें चेंज करें तो हम लिख सकते हैं rho raised to the power 1 minus gamma into T is equals to constant. So if I apply this equation at lower and upper end, so we can write these things. So from here we can find out the value of ρ2 as 0.1 kg per meter cube. Since ρ1 is already known, T1 is known, T2 is known. So if I substitute all of the values in this equation, so we can find out the value of ρ2 as 0.1 kg per meter cube. So if I observe option D, so it is saying the density is 0.05 kg per meter cube. So option D is also wrong. Density is 0.1 kg per meter cube, not 0.05 kg per meter cube. So now I will solve option B. In option B, we have to find the velocity of gas entering and velocity of gas coming out from the upper end. So this is our setup. So since it is given in the question the mass entering into the chamber is alpha. So the quantity of mass entering into the chamber will be equal to quantity of the mass coming out of the chamber, that is dm by dt in will be equal to dm by dt out, and it is equal to alpha already given in the question. So we can write dm by dt entering as rho a1 into v1, since rho a v1 a into v is volume and rho is density. Rho into volume will be equal to mass. So if I write rho 1 a1 v1 equals to rho 2 a2 v2, that will be equal to alpha. So we can find out the value of v1 and v2 from these two equations. Since alpha and rho 1 a1 rho 2 a2 are already known, so if we substitute all of this value in the equations, we will get v1 as 40 meter per second and v2 as 20 meter per second. So in option B, the velocity at lower end is 40 meter per second and at the upper end is 20 meter per second. So it is the correct option. So it is correct. Option B is correct. Now coming to the option C, we have to find the height of the chimney. What is the height of the chimney in this case? So let me assume at any time t, in next 1 second, this much amount of volume of ideal gas V in enters into the chamber, and this much amount of V out, this much amount of volume come out from this chamber. So we can write V in as mass by density, mass entering, that is alpha, and density at lower end is rho 1. So V in is this much value. Similarly, V out will be alpha by rho 2. Now since it is ideal gas, so we can write internal energy as n by 2 into FRT. Now we can write number of moles as mass by molar mass. So mass entering is m dot by m naught into FRT. Now we can write RT by m naught together, since we know Pm naught is rho RT. So from this equation we can find out the value of RT by m naught as P by rho. So substituting the value of RT by m naught as P by rho, we can write the internal energy of ideal gas as alpha P by rho. So here internal energy of gas is only in the term of pressure, density and dm by dt, that is alpha in the question. So now if I apply work energy theorem on our system, this is our system. So if I apply work energy theorem, the work done, net work done will be equal to P1 into V1, P1 into V1, and this system will themselves will do a work of P2 into V2. So the net work done will be P1 into V in minus P2 into V out. So this is the net work done on the system, on this system. So the net work done can be written as change in kinetic energy plus change in gravitational potential energy plus change in internal energy. So the final kinetic energy will be half alpha into V2 square, initial kinetic energy will be half alpha into V1 square, and change in potential energy can be written as alpha GH. So alpha GH will be here, and change in internal energy can be written as final internal energy will be alpha and P2 by rho 2. So this is the final internal energy UF, and this is the internal energy of the ideal gas UI. So this is the change in internal energy. Now if I borrow all of these terms into the left side of the equation, we can write GH equals to this much, and if I find the value of h from this equation, if I put all of these known terms, since all of these terms p1, rho 1, p2, rho 2, v1, v2 and g, all of these terms are already known. We have calculated in previous options all these terms. So if I substitute all these terms into this equation, we can find out the value of h as 360 meter. So in option C, I see the value of height of chimney is given 590 meter, but it is coming out as 360 meter. So option C is wrong. Option C is also wrong. So only option B is correct. Only option B is correct.